Hey everybody. So in this video, we are going to explore a new model called the BioMistral model to build a RAG application using Langchain and free Colab. So we are going to use a PDF document that contains a heart's data, right? So we are going to feed this data into the large language model to answer questions that relates to the heart. So with this kind of application, you can include any medical data from any specific medical domain to answer a specific question, right? So I've already tested this out and it looks promising. So the BioMistral is an open source large language model specifically designed for biomedical application. It's built upon the Mistral foundation model and pre-trained on the PubMed Central data. Through a rigorous evaluation on 10 established medical question and answering tasks in English, the BioMistral demonstrate a superior performance compared to existing open source medical models and competitive performance against its counterpart. So the study explores the creation of lightweight models through quantization and model merging techniques. So it addresses the limited availability of data beyond English and to assess the multilingual generalization of medical LLMs. So it means that it automatically translated and evaluated this benchmark into 7 other languages. So this marks the first large-scale multilingual evaluation of LLMs in medical domain. All right, enough of that. So let's get into the collab and see how this model performs. All right, so before we do that, I'm going to briefly take you through how this works. So the architecture, we are going to upload a PDF. In this case, we are going to upload this health data. So it is a 95 page healthy heart data. So we are going to specifically upload this data to be passed to the LLM to answer questions that relates to the heart health. All right, so it has information like the blood pressure, the congestive heart failure. So it has contain a lot of information with the heart. Okay, so we are going to in let me take you to the so this is going to be the PDF uploaded. In this case, it's going to be the health data. We are going to extract the information from the PDF and we're going to split that into chunks. And we are going to create chunk one, chunk two, chunk three, chunk four, like that. So for each of the chunks, you are going to create embedding for that to be fed into the large language models. So we are going to store that into a knowledge base. So we create a semantic index in here. So we are going to find relevant document based on the similarities and information from the original question. All right. So that so for the knowledge base, the vector store, we are going to use the Chroma. So we can use the files in other open source vector storage. All right. So that when the user asks any questions, it comes in here and creates embedding just like this one and try to create understanding into the knowledge base. It gets a similarity and it passes that to be ranked. So it ranks, let's say, the top four, the top three, and it passes that to the LLM. So in this case, the LLM is going to be the BioMistral. Okay. So it then creates the best answer and passes that to the user. Okay. It's pretty simple. All right. So in here is the collab. All right. So we are going to need to pip install Langchain, the face CPU. In this case, I don't need this one because we are using the Chroma. Langchain sentence transformers, Chroma DB to create a vector store. The Llama CPP, we are going to load the model through the Llama CPP, and we are going to use the Langchain community and the PyPDF to read the PDF. All right, let me rerun this again. So we import the libraries, we import the PyPDF directory loader to load a PDF. So we load that from the Langchain community, and we do the character split text splitter. Okay, in this case we only need the all right. So you can either use any of these, the character text splitter or the recursive character text splitter. So we have to split the text. So we use the Hugging Face embeddings to load the to create embeddings. So in this case, you can use any of these vector storage. We are going to use the Chroma and the Llama CPP to load our LLMs. In this case, the BioMistral, and we are going to create the chain using the retrieval keyway chain. So I'm going to run this. All right. So we import the path lib. So the text wrap, we want to wrap the text into a markdown so that the outputs become so nicer. All right, so let me run this. All right, so we want to get the API key. I'm going to show you in a second. So in order to get that, we import OS, from getPass, import getPass. All right, so let me run this. I'm going to show you how this works. All right, so in order to get the API key from Hugging Face, you first go to your Hugging Face, you go to settings, and you go to access tokens. In here, it's going to be your access token, so you can just copy that and you come in here. Okay, so you click on the key sign and you can see the here it tells you add new secret key, so you can put a name here for your key. So in this case, is the Hugging Face Hub API token, and you paste your API key here. All right, and you can choose any of these to turn it on or off. All right, so we import OS and we say os.environ is equal to the Hugging Face Hub API token. So you can grab the API key just by running this code. So the next thing we need to do is we import the document, the PDF document. In this case, I've already uploaded it. Right, I've created. So we just copy the folder in which contains the PDF document. So you say copy path and you paste it in here. All right, so we use the PyPDF directory loader to load the PDF files, and we create a variable called the docs and we load it using the loader.load. So let me run it. All right, so I already have the documents here. So when I run the documents, you can see all the documents can be seen here. So when you move it up, you can see the documents here. So what we want to do next is to split that into chunks. So we create a variable called a text splitter. Use the recursive character text splitter to split that. So we make a chunk size of 300 and we will have to be 50. So when I run this, so in here, so when we split the documents, we feed that into a variable called chunks. So when we run this, this is the length of, so we have 747 chunks, right? So let's look at the first index. So as you can see, these are the chunks. So this is the first index. So you can see your guide, Healthy Heart, Department of Health and Human Services. So this is the index. And let's look at the next one. You can see the next one. It's the next chunk, and the next chunk, and the next chunk, right? Great. All right, so now we create the embeddings. So we are going to say we are using the Hugging Face embeddings from Hugging Face, and we are using this embedding model. All right, so you can get in here and choose a model, an embedding model. In this case, I'm using the BAI with the V1 1.5 version. So I'm using this one. So you can just copy that and you can paste in here. Okay. So if you run that, right, it's creating. Okay, we are done with that. And now we want to create a vector store. So for each of the text, as you can see here, Chroma is going to be the vector store from the document. So for each of the chunks we've created up, we want to create embeddings for that. Embedding is nothing but converting each of the text into numbers. So we can pass that to the LLM. In that case, it's going to be the BioMistral. Okay, it's running. Right, so that is done. So let's run it. See, right, so we have the vector store created. Right, so it's from vector store.chroma. So the next thing is let's perform a similarity search and see. So I've saying a query is equal to who is at risk of heart disease. And when I run this, right, let's create a markdown. So this is where the context can be found. So an important risk factor for heart disease and other medical disorders. Okay, so he's trying to find a similarity that is linked to the query. Okay, so let's move on to create a retriever. Right, so it's going to retrieve from the vector store. It's going to retrieve the top 4 searches. So in this case, we create a variable called a retriever and we pass the vector store. So as the retriever, we pass in the top 4 searches. And when you run this, right, so we are saying that get relevant document from the query. And let me run this. So as you can see, this is the query that I passed. And I wanted to get the top 4 searches. And you can see this is the document based content, an important risk factor for heart disease and other medical disorders. Right, so it's giving me the top 4 searches. So it says in the document one, one, two, three, four. All right, so you can extend it anyhow you want it. All right, so in case I do it like 5, let me see. All right, so you can see 1, 2, 3, 4, 5. So these are the searches. It contains the top 4 of that relates to the query. So the next thing is we now want to create the LLM, pull the LLM. So we are connecting that to the Google Colab. So I'm going to show you how you can get this model. So I am running the BioMistral 7B. That is the key for GGUF. So I'm running the GGUF. So if you want to pull that, you can go to the BioMistral on Hugging Face and you say BioMistral. Because I'm doing the GGUF, I'm going to go to the GGUF and you go to files. So in here, I'm using the KMGGUF. So that would be 4.37 gigabytes. So you go here and you download it. Alrighty. So I have this in my Google Drive. Right. As you can see, I have the model here. So I'm going to load the model. So I'm going to say google.colab. I'm going to import this. It's already imported. So I'm going to say drive.mount. I'm going to mount that. Okay, so I'm going to say run this one. So already connected to that. Right. And now I'm going to do now is let me run the LLM. I've already run it, so it should not take a long time. For the first time, if you're running it, it's going to take a long time. So in here is my using the Llama CPP, and this is the model path. Okay, so in here is the model is stored in my drive. So as you can see, my drive, and I have the, okay, so you can see this is the model. So in order to copy that, you go to here, you say copy path. So you only need the path. So you just come in here and you paste it. Okay, it's really easy. So actually it points to the direction where you have your model stored. In this case, I have it stored in my drive. So I just have to copy the path and paste it. All right. So the temperature is going to be zero point 0.3. The max token is 2048. Top P is equal to 1. So you can just change it, play around with it. So it's already run. So I'm going to create a rack pipeline or the chain. So here I'm going to need the runnables. So I'm using the Langchain schema, those runnables. So runnable pass through is just nothing but it's going to allow us pass the input or with the addition of extra key. So it's going to help us run the input. And the output parser is going to be the pass the output from the model. Okay. All right. So let me run this. And this is the template. So the template, we have the context. So you are an AI assistant that follows instructions extremely well. So please do be truthful and give the direct answer. So we are passing the user. So this is the query. Going to pass the query and the assistant. So this is what we are going to get from the model. That is the answers. All right. So when I run this, so we create a prompt and we are passing the chat prompt template. So we pass the template that we've created, pass the template into the chat prompt template. And now we want to create the chain, the rack chain. So in here, we are passing the context. The context is the retriever that we've created, and the query is the runnable pass-through. So it is going to use to pass the input. All right. And we are piping the prompt that we've created and the LLM and the output parser, right? To pass the output from the model. All right. And let me run this. Okay. So the next thing we want to do is create a variable called the response, and we want to pass the query into the rack chain. So when you say run, so run this, it's going to take just a little time. It's making everything ready so we can start asking questions, chatting with the model. All right, so it's set up. So let's see, you can load time, sample time. So now let's say response and let's see the output. We are saying, why should I care about my heart health? So when I run this, right, and it's putting that into a markdown really nice. So because your heart is one of the most important organs in your body, it's crucial to take care of it. So a healthy heart can help prevent or manage many health problems like high blood pressure, stroke, or heart disease. So there are many ways to take care of your heart, like eating a healthy diet, being physically active, managing stress. So taking care of your heart can really also help you feel better now and on in the future. I think I like this response. It's really, really awesome. All right, so let me just say, what disease, a disease affects the heart? All right, so let me run this. All right, so let me run this. All right, so the heart is, I say, what disease affect the heart? The heart is affected by many diseases, some of which include the coronary artery diseases, cardiomyopathy, endocard- endocarditis. All right, guys, it has a lot of technical words, so I wouldn't say that. So I know hypertension and heart valve stenosis. Well, guys, I really love this response. So all right, so you can just do like put a while loop in here. All right, so let me just run it and try something here. So let's go into the PDF. Let me ask a question, similar one from here. Okay, all right, so let me just say, what is heart disease? Okay, let me try this. What is heart disease? Is heart disease. It's enter. All right, so it's saying a heart refers to a group of conditions that involves the heart and blood vessels, including the coronary artery disease, heart failure, arrhythmias. Right, guys, I think it's perfectly aligns with what we are just seeing here, which is a very great response. Yeah. All right, so let's get back to it. You can see this is awesome. So he's saying the congenital heart defects can cause symptoms such as shortness of breath, fatigue, and swelling in the legs, and can increase the risk of premature death. Right? Yeah. So you can just continue asking several questions. Okay, just keep playing with it, and I'm gonna attach the link in the description so you can grab the file and play with it. So let me know in the comment section how you think about this model, and do well to subscribe and share, and see you in the next one.